This is a Maths Worksheet 3, Chapter number 1, Knowing Our Numbers. In this worksheet, we will discuss about word problems related to Chapter number 1 and exercise 1.2. And here we will solve some questions also from exercise number 1.2. Now, hello students. So, today we will solve some examples and questions related to Chapter number 1, Knowing Our Numbers. In the previous video, we will solve some word problems related to chapter number 1 and from exercise 1.2. So there are some other questions also. So here today we will solve some these questions. Now here we take question number 2 from exercise 1.2. Here the question is, Shekhar is a famous cricket player. He has so far scored 6,980 runs. In test matches. He wishes to complete 10,000 runs. How many more runs so here the question is, Shekhar is a famous cricket player and he has so far scored 6,980 runs in test matches. He wishes to complete 10,000 runs. So how many more runs does he need? So here now first we write runs to achieve equal to 10,000 runs. So here runs is scored by the Shekhar 6,000. So here we find how many more runs does he need. Here we subtract 6,980 from 10,000. So here 0 minus 0, here 0. Now here we take one borrow from here. Then here 9 is left. Then here 10. Then 9 here. So 10 minus 8, 2. 9 minus 9, 0. 9 minus 6, 3. 3,020 more runs. Now here I take another example related to chapter number 1, Knowing Our Numbers. Here the question, find the difference between greatest and least numbers that can be written using the digits 6, 2, 7, 4, 3, each only once. So now here the question is, find the difference between greatest and least, mean smallest numbers that can be written using the digits 6, 2, 7, 4, 3, and each digit repeat only once. So now, in order to generate the greatest number, we arrange the digits in descending order. So here we write the greatest number. So here 7, 6, 4, 3, 2. So here we get the greatest number by using these digits 76,432. Now we find the least number. So when we find the least number and to generate the smallest number, the digits are arranged in ascending order, mean smaller to greater. So here we write, and from write this number, greatest number, from the one side like 2, 3, 4, 6, 7, and we arrange the digits in ascending order, mean first we write 2, then 3, then 4, then 6, then 7. So here we write 2, 3, 4, 6, 7. So now we get the least number or smallest number by using these digits 23,467. Now we subtract these two numbers 76, 432 minus, because here we get difference, so 23, 467. Now here we subtract these two numbers. So now here we take one borrow from 3, then here we get 12 here, and here 2 is left. So 12 minus 7, 5. Now here again we take borrow from here, so here 3 is left, and here 12. 12 minus 6, 6 here. Now again we take one borrow from here, from 6, so here 5 is left, and here 3, 13. Then 13 minus 4, 9. Then 5 minus 3, 2, and 7 minus 2, 5. So here we write hence required difference is equal to 52,965. Okay students, so here remember these things when we find and generate the greatest number, then we write this digit in descending order, and when we generate least number, then we write the digits in ascending order. And here we find the difference between the greatest and the least number, then we subtract least number from greatest number, and here we get 52,965. Now here we solve another question from exercise 1.2, question number 6. Dear students, you also note down these questions in your fair notebook. These all questions in your fair notebook. And you also try this question in your rough notebook also. A machine on an average manufactures 2 comma 8 to 5 screws a day. How many screws did it produce in the month of January 2006? So dear students, here first we find total number of days in January month in the year of 2006. So if the question is, a machine on an average manufactures 2825 screws a day. How many screws did it produce in the month of January 2006? So here we write total days in the month of January 2006 is equal to 31 days. Now, number of screws manufactured in one day. So in one day, total 2825 screws produced in one day. So here we write number of screws manufactured in one day equal to 2825. Now we write number of days in the month of January 2006 is equal to 31 days. Now we find the total number of screws produced in the month of January 2006. So here we multiply 2825 by 31. So here we multiply 1 by 5, then we get 5, 1 to the 2, 1 8 the 8, and 1 to the 2. Now 3 5 are 15, 5, 1 carry, 3 to the 6, 1 7, and 3 is 24, 4 to carry, 3 to the 6, 7 8. Then we add these numbers. Now here we get 5 5 6 7, then 7 8 15. Now here we write 15 here, 5 1 carry, 4 1 2 3, 3 and 4 7 and 8. So here we get 87,575. So here we write therefore the machine 87,575 screws in the month of January. Now students, here we take another question from exercise number 1.2, question number 7. Here we find how much money will remain with merchant? Question number 7. A merchant had rupees 78,592 with her. She placed an order for purchasing 40 radio sets at rupees 1200 each. Mean the cost of one radio is equal to 1200 rupees. How much money will remain with her after the purchase? So here we write cost of one radio is equal to 1200 rupees. Now we find cost of 40 radios. So cost of 40 radios is equal to, now here we find the cost of 40 radios. So here we multiply 1200 by 40. So now here we will multiply 1200 by 40, the cost of one radio and the total radios. So here we use shortcut method of multiplication. So here we multiply only these numbers, 12 4s are 48, and after that we put total zeros, 1 2 3 1 2 3. So here we get 48,000. So here the cost of 40 radios is equal to 48,000. Now total money with merchant. So here the total money with merchant is equal to rupees 78,592. She spent total money is equal to 48,000 rupees. So here money spent by her 1,592. Now we subtract 2 minus 0, 2 here, 9 minus 0, 9, 5 minus 0, 5, 8 minus 8, 0, and 7 minus 4, 3. So here we get total 30,592 rupees. So here we write, therefore rupees 30,592 will remain with her after the purchase. Now here we will solve another question from exercise number 1.2. Question number 9. To stitch a shirt, to stitch a shirt 2 meter 15 centimeter cloth is needed. Out of 40 meter cloth, how many shirts can be stitched and how much cloth will remain? Now the question is, to stitch a shirt 2 meter 15 centimeter cloth is needed. Mean one shirt required 2 meter 15 centimeter cloth. So out of 40 meter cloth, how many shirts can be stitched? Mean how many shirts stitched from 40 meter of cloth and how much cloth will remain. So here we write cloth required to stitch. Now here we change this meter into centimeter. So here when we convert meter into centimeter, we multiply by 100. We multiply the number by 100 and then we get 200 centimeter plus 15 centimeter. Then we get 215 centimeter. Here the cloth required to stitch a one shirt equal to 215 centimeter. Now length of cloth equal to 40 meter. Here we also convert this 40 centimeter, then we multiply 40 by 100 centimeter, then we get 4000 centimeter. Now the number of shirts can be stitched equal to 4000 divided by 215. Now here we divide 4000 by 215. So 215 divide 4000 one time, then we get and subtract 215 from 4000, and here we get 1850. And after that here we divide 1850 by 215. So here 215 divide 1850 in 8 times, then we get 1720. 18 shirts can be stitched and 130 centimeter, and we also write 130 centimeter as 1 meter 30 centimeter cloth will remain. So dear students, in this exercise I solved some questions. I also give some questions related to chapter number 1 and from exercise 1.2 in your worksheet. So you will solve all these questions in your fair notebook. Okay students? Thank you students.